Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
Okay, so this video is totally unplanned. I was just taking a break from my other work, and I thought, we did the mean on that mean monthly fire intensity. And in all my previous videos, I showed that using the median is the preferred option. So I thought, let's quickly try the median, and the results are very interesting. So I thought, let me do a video tutorial on this, again showing the difference between the mean and the median, and why the median actually is the preferred reducer rather than the mean. Okay, so thanks everybody. Our subscribers have increased a little bit. There seems some movement there, but please, we're still way below. I need to get to the 500. And then it's the 1,000. So please press those buttons left, right, and center. Let's go. Okay, so as I said in the previous video tutorial 145, we basically, when we generated the mean monthly fire detection, we exported that data into Excel, and then from Excel we imported it into RStudio, and from RStudio we did the decomposition, etc. And so so I thought, I've been talking so much about using the median, yet I've used the mean. So again, as I said, totally unplanned, but that's my curiosity. It shows you this is the captivating nature of this damn work. So I thought, okay, let's do the median, and I've just amended the two parts of the script there. There used to be mean. If you go back to that previous, you'll see it was mean, so I just started to median. And here also reduce, I changed it to median. Remember, this sum here, it's got nothing to do with the values. It has to do with the number of pixels. Okay, so here we don't change anything here. We leave that to sum. As I said, it's not adding the intensity. It's just getting the total pixels that recorded fire detection. So that's where this comes in. So leave that. It's only the median, the image collection, the values, and then the reducer here. And this is what we get to. Now, in essence, the graph looks very similar, although the trend seems to be more steep downwards. But you can see this one is quite new, but you can see that one was evident as same as these ones. So from just comparing the two charts of the mean versus the median, it doesn't look too much of a difference. So that on its own doesn't seem to be anything to write home about. But as I said, let's move it to RStudio and go and have a look. So what I've done, okay, so we download, etc. Okay, so now I'm in RStudio. So what I've done in RStudio, if I open my data, you'll see I've just had now a mean and a median. A mean, fire mean, which is the one that we used to work with, and now I've also created the fire mean. You'll see there's some differences in the numbers. But the months that didn't have mean values also didn't have median values. Okay, so just so those months, I think there was 20 of them, those months we've excluded. And I've loaded, and all the same, but as I said, now I've got a mean and I've got a median. So all I did the mean, I did FA, A for average, and M for median. So FA is the fire mean reducer, and the FM is the fire median reducer. So with the mean monthly fire intensity and the median monthly fire intensity. In general, intuitively, there shouldn't be much of a difference. However, let's have a look. Okay, so now I've created the script to plot the two. Okay, so I'm going to plot the two. Okay, so there is the mean one. Frequencies, monthly, start date, medium, exactly the same. I just call it series 1 and series 2. So time series 1 is the mean fire intensity, mean monthly fire intensity. I must get this right. I'll get it right. And series 2 is the median monthly fire intensity. Okay, so just a small, so mean is the average one, and median is the one that lies in the middle, for those that don't know. Okay, so I'll just create the plot to plot the two, and there it is. Okay, so let's quickly zoom it and see there is, okay, there's the difference. There's the difference. And you can see if you overlay this, there is some significant differences. There is really some significant differences. And remember, if the average or the mean value is more than the median value, that means you have outliers on the higher side. You have a few very big values and a lot of small values. Few big values, a lot of small values. That seems to be the case. You had one or two massive fires, and one or two massive fires that skewed it to the positive. If you had it the other way, which I don't so much see here, then it would be a lot of one or two small fires and a lot of big fires if it was the other way around. So just go and read up on the difference. It's positively skewed or negatively skewed. Okay, so the difference between the mean and the median by itself tells you quite a bit of the distribution of the data. Okay, so that's quite interesting to do. So have a look at that. So yeah, so here it definitely seems that there's some big differences between the two, between the mean monthly fire intensity and the median monthly fire intensity. Remember, the median, the value lies in the middle. Okay. So by that, yeah, this looks interesting. So we have to look at it. We have to play around with it. Okay. So now I've loaded my data set, and I've included the mean and the median, and I've again, if you look here, I've omitted my data, those months that recorded 0 fires, which I think was 20, if I'm vaguely, I think it went from 283 to 260 something. Anyway, I can do it here. Let's run it quickly again. 283, and if I do this, 263, so it's 20 months in a 24-year period where there was no fire detection. So that means almost every day there's some sort of fire. Okay, so let's run it again. I'm just going to quickly do all these things just to make sure that I've covered everything. Okay, there we go. The values. Okay, so let's leave these, and I'm going to go to this. So let's quickly have a look and see the differences. So there's my decomposition of the mean. Okay, so there's my decomposition of the mean. Okay, this looks familiar. Should look familiar with those two big ones there. The values increasing here, etc. etc. So let's have a look at that. Now, here's my decomposition for the median. Remember, the A is for average or the mean, and the M is for the median. So let's run that one as well. I just want to quickly make sure I have. I just want to sure I have created those time series, that fire average and the fire median time series. Okay, so let's just make sure. Okay, so let's run it again. Just want to make sure, always make sure. Okay, and then the median one. So let's export that one. Zoom. Okay, so it's already zoomed. Okay, so it still has a 2, but you can see there's clearly a decrease there. And there's 2 spikes here. So there's quite a, as I said, a difference here. It still has the upside, but it's on the decrease here, medium-wise. Where mean-wise, it's still on the increase. It's got these 2 spikes now. It's got a couple of more spikes in the, what I call the natural fires than the man-made. The man-made fires also looks a little bit different. So let's have a look again at that. You'll see, you'll actually have to put them side by side to see the differences, but you can see there's by itself a difference. You can see here's also a difference. So there's some significant differences between the two in terms of its decomposition. But yeah, we literally have to overlay these to actually look at it. But yeah, I just want to see the numbers 0.5, 0.5, 1.5. Let's quickly have to look what those numbers look like. Yeah, this looks like there's a bit of a change. 0, 1, yeah, it's definitely higher, more. Yeah, you can see there's definitely a difference between the decomposition of the two. But I think where we get the difference more clearly, we get the difference more clearly when we do the ARIMA models. Okay, so the first one I'm going to do is run the ARIMA model on the mean values. Okay, the mean values. Okay, so we're going to run the model, we're going to check, etc., etc. Okay, so let's run it. Okay, so there is our there's our accuracy measures. Mean error. So okay, so these are measurements between that measure the difference between the actual and the predicted. Okay, so this is our standard error of standard forecasting methods, accuracy methods. Okay, so let's go mean error, root mean square error, mean absolute advantage, mean percentage error, mean absolute error, mean percentage error, mean absolute percentage error, mean average, can't remember this, and this is autocorrelation. I can't remember what was this one now. Mean absolute standard error. I can't remember, but anyway, these are all measurements of the forecasting error, because remember what we're doing, we're forecasting. Just by the way, if we do the forecast, 2-year forecast, we can do that, and there it sits. Okay, so there we've done the forecast. There we've done the forecast. Okay, there's the forecast according to the mean monthly fire intensity. So that is the values that we're interested. We're looking at these values here. Also, by the way, it's interesting that the model is an ARIMA, and it's got, you see the importance of the seasonal? Well, it's not that important because it's got a very, very low coefficient, but there's definitely a seasonal element. So this is an AR element, an autoregressive element, meaning its dependence on its own self value, its lag value. Okay, so that's depending on its lag value. Then there's a, which is also quite lowy, so it doesn't really depend much on its period, simply because it's stationary. So I would expect that if your time series is stationary, your AR should be very small. Okay, so it is stationary, but your moving average is quite high. There's quite a high moving average, so depending on the error component. So it's a 1, 1, 1, okay, and it's a 12 period. So 1 AR, okay, remember it's autoregressive, which is 1, integrated, which is 1, meaning stationary. So it's been difference 1 to get stationary, and then moving average 1. And then it adds this one component here, which is the seasonal pattern. Seasonal is low. There is seasonal influence, as I showed, but it's fairly lowish. But it's mostly this error component that it's dependent on, and that is its gives it accuracy measurements. So remember, we want these values to be as close as possible to 0. Okay, we want no error between the predicted and the actual. We want the actual and the predicted to be the same. So what these measures, what these indicators measure, is the distance or variance between the two. So we want these values to be as small as possible. Okay, so then let's quickly then also test the median. Okay, so I've got the median here. So let's test those two. Okay, so there they are. So let's quickly have a look at and stuff. Let's see which is. So the mean error in this case is minus 0.3. The mean error is 0.25. So 1 for the median, 0 for the mean. Let's look at the root mean square. The root mean square error is 6.6. Here the root mean square error is 5.7. Too low. Let's have a look at the mean absolute error, 4.8. And here it is 4.0, 3 low. Let's look at the mean percentage error, minus 0.13. And this is 0.11, 4 low. Let's have a look at the mean absolute percentage error, 1.15. 1.29, what's it now? 1, 2, 3, 4, 5 low. This one here, which I presume is the mean absolute standard error or something, seasonal error, I can't remember, 0.8. And this one is 0.799. Yes, that's very close. So, yeah, this is marginal, but what's it now? 1, 2, 3, 4, 5, 6 low. And this is the autocorrelation, which is minus 0.01. And you can see this is 0.005. Much better. So the median, using the median monthly fire intensity statistics, gives you much more reliable model than if you use the mean monthly fire intensity. Just to also show you the difference is that, have a look here, the ARIMA model, when we looked at the median, remember M is for median, is 0, so there's no autoregressive. It's integrated, and it's got 2 error components, moving average components, and it's got its seasonal. Seasonal is 0.0447. Let's have a look and see. 0.0447. So very, very similar. Then you have the moving average, minus 0.944. Similar, but you also have a second moving average term. So excluding the average, the autoregressive, including a second moving average term, improves the model much more. It's much more accurate or reliable, accurate and reliable than if we look at the mean. So let's quickly, if we plot the, where is it now? If we plot the forecast from the mean statistic, that's what we get. So have a look at this, see if we can make a mental note of this. And if I plot it using the median, let's run it again and see where it now looks. Well, it's difficult to say, but if we just look at here, okay, so let's come on, let's just look at it in that. If we do it now, you can see the variance increase. You can see this part here narrows. Okay, so that's exactly, if we overlay, so if we overlay it, so that is to be expected, because if we present the two data, have a look at this now. If we present the two, you'll see that the median, the variance on the median is much less than the variance on the mean, and that's why it's performing much better in our modeling, yields much better results when we model it than the mean. It's because of this variance issue, because of the variance. So the variance on the median is much smaller, and therefore when we include the median in our modeling, we get better results than when we use the mean. So the mean is more susceptible to outliers, which skews our coefficients. So when we use the median value, we eliminate those outliers, the influence of those outliers. And therefore our skewness, our variance in our time series decreases, and that obviously improves the results, makes the results much more reliable and accurate. So just again, as I said, I didn't want to do this. It wasn't the plan to do this, but as I said, I thought, let me just see whether whether using the median is going to be better than the mean. And voila, again, like I said many times before, using the median statistic or reducer is more optimal, it's better, it's more effective than using the mean reducer. Okay, so just make a mental note of that. And if anybody asks you why, then refer them to this video tutorial. And because in this video tutorial, we statistically prove that using the median reducer is much better than using the mean. Now, whether it's always going to be the case, who knows? But in all my workings so far using Google Earth Engine, in almost all cases, well, in every case, the median reducer has been optimal, has been outperforming the mean reducer. So that's just by the way. And also so that's basically what I just wanted to show you in this video. It's a little bit of a detour, it's an unexpected video, but still I think quite interesting and fairly useful to be able to fundamentally understand the differences between using the mean and the median reducer. Okay, so that basically means that within our charts, our time series work within Earth Engine, we should convert all our mean to median. Okay, our mean to median, and then continues from there. So let's end this video tutorial here. Let's end it here. As I said, unexpected, but I think worthwhile. I think it's interesting, and it proves what we were thinking about, or reinforces what I've said all along, in that using the median is the better option. Anyway, anywho, that was thank you very much for joining me on this video tutorial. Thanks for your grateful support. I really appreciate it. For those that haven't yet subscribed, please do so. Smash those buttons, like, share, send me your comments. I really appreciate it. And stay tuned. I'll see you on the other side.